In this video, I'm going to briefly introduce you to the concept of a mole in chemistry, but that's not going to be the major focus of this video. We're going to try to look at how to do molar mass and percent composition. Okay, so in chemistry, we can measure things by mass, we could do volume, we could count individual pieces. If we were measuring mass, we could use grams. Okay, put things on a balance. If we were doing volume, we can measure in liters, put it in a graduated cylinders. Uh, so if you were counting numbers, you could use, dozens, you could do a gross, you could do like a ream of paper. But in chemistry, we count things in moles. Okay, so like I said, that's not going to be a major focus of this video, but it's just trying to show you here that literally a mole in chemistry is like an amount. As you'll see, moles are very important in chemistry, but in a lab, they're not too useful because we don't have anything that measures directly in moles. So being able to get moles to grams is very important because we can easily measure grams in a lab using a balance. So there's a quick conversion here that we need to know. We know that for 1 mole of any element, it's equal to its atomic mass in grams, okay? And you get this number right from the periodic table, all right? So for example, if you look up arsenic on the periodic table, 1 mole of arsenic would have about 74.9 grams in it, okay? So about 75 grams, all right? And you get that number right from the periodic table. If you look on your periodic table, that would be the atomic mass, the number with the decimal below it. Okay, and typically we allow you to round these numbers to the nearest whole number. So for example, if you had 1 mole of aluminum, okay, if you look up aluminum on your table, 1 mole of aluminum would have about 27 grams in it. All right, so all you're doing is getting these numbers right from the periodic table. If I were you, I would look on your periodic table, make sure you know what number we're talking about. Okay, so if you pick another one like iron, okay, find iron on the periodic table. If you had 1 mole of iron, you'd have about 56 grams of iron. Okay, so it's a very important conversion that we're going to use a lot here. So this picture is just showing you 1 mole of different substances. For example, if you had 1 mole of carbon, you'd have about 12 grams of carbon. Again, you get this number right from the periodic table. If you had 1 mole of sulfur, you'd have about 32 grams of sulfur, and so on. Okay, so you just have to look up these numbers right from the table for each element. We're going to use this idea of moles to be able to calculate molar mass. Okay, molar mass in chemistry is the mass of 1 mole of an element, molecule, or compound. And it's a very simple calculation. You use molar mass a lot in problems, so you need to know how to do it, and you need to be quick and do it correctly all the time. So I'll go through the steps here, but I think just seeing examples will be more helpful for you. So the first thing you do is you literally have to figure out how many moles of each of the elements there are in the formula of the compound you're trying to find the molar mass for. So you just look at the formula and see how many there are of each of the individual elements, okay? So the elements themselves are important here, all right? Then what you do is you look up the mass of each element on the table. You are allowed to round these numbers to the nearest whole number, all right? You will multiply the mass of each element by the number of each element there are in the formula, and then you get your numbers, and then the last thing you do is just add up all your different masses, and that will give you your total molar mass here for 1 mole of the compound. All right, so our units for molar mass are going to be grams per mole. So as we go through an example here, you'll see how to do this. You'll use these steps, and I think you'll see it's pretty easy. The first example we're going to do here is glucose. We're going to find the molar mass of glucose, which is C6H12O6. You might remember that from biology. Okay, so first thing you do is just figure out which elements are involved and how many you have of each element. Well, those numbers are right in the formula. Okay, so the first element I see in the formula is carbon. All right, so I have carbon, and there are 6 carbon. Okay, the next element I see is hydrogen. All right, and then I have 12 hydrogen, and then I see oxygen, and I have 6 oxygen. Okay, so you just get the elements, get the numbers right from the formula. All right, but then you say, okay, well, if I have 6 carbons in this substance, what's the mass of each carbon? So when I go to the periodic table, again, you need to have your periodic table out for these problems. If you look up carbon, he has a mass of 12.01. You're allowed to round that to a whole number. So each carbon has a mass of about 12. All right, so when you do this, there's 6 carbons, each has a mass of 12. That is 72 grams here. Okay, so just from the carbon in this compound, you have 72 grams coming. All right, well, then we have hydrogen. When you look up hydrogen on the periodic table, the mass of each hydrogen is about 1. All right, so 12 times 1, you have 12 grams coming just from the hydrogen. And then the last element here is oxygen. When you look up that on the periodic table, it's about 16. So you have 6 oxygen times 16, which is 96 grams. Okay, so just be careful here. Some people look at this when they're doing it really quick, they think that that's 60 and they multiply 60 times 16. So just be careful. It's 6 oxygen, 6O. All right, so these are the masses of each of the individual elements in glucose, but we want to know the molar mass here of the entire thing. So the last thing you do is just add this up. So when you add up those numbers, you get 180, and the units are grams per mole. Okay, so we say the molar mass of glucose is 180 grams for every 1 mole. So if I told you to go measure out 1 mole of glucose, you would measure out 180 grams of it. All right, so that's how you calculate molar mass. This picture is just showing you the molar masses of some different substances. So we just did glucose, all right? So we know that there's 180 grams of glucose for every 1 mole. So they're trying to show you about how much that would be in a beaker. When you do the molar mass of water, there's 18 grams of water for every 1 mole of water, and so on, okay? So this is something you can easily calculate for any element, compound, or molecule. We're going to try a couple of examples here real quick, and usually people pick this up pretty quickly. So if you feel like you got this, pause the video, try it on your own, and then check your answer and move on to the next one. All right, so we're going to do this for Na2S, sodium sulfide. All right, so you remember here, we need to worry about each of the individual elements and how many there are. So the first element I see in this formula is sodium. All right, and there are 2 of them. And then I see sulfur, and there's just 1. All right, so when I look up sodium on the periodic table, when you find sodium there, he has a mass of about 23. All right, so there's 2 sodium times 23 is 46. And you'll notice that as you start to do these more and you start to use the elements, some of the elements you'll just start to remember. You'll know exactly how many uh, or what the mass is of each of them, and you won't have to look it up. So that's really nice here. So sulfur has a mass of about 32. So when you do 1 times 32, you're getting 32 from the sulfur here. So those are the masses for each of the individual elements. The last thing I got to do here is total this up. So when I total this up, I get 78 grams per mole. Remember, your units here are grams per mole. Next example we're going to try is N2O4. So again, we care about the individual elements here. So first element I see is nitrogen. There's 2 of them. All right, so 2 times 14 is going to be 28. All right, remember, I'm getting that mass of nitrogen right from the periodic table, and you are allowed to round it to the nearest whole number. We allow you to do that here. All right, then I have oxygen, and there are 4 of them, times 16. Again, it's 40, not 40. So 4 times 16 here is going to be 64. And the last thing you do is add these up, and we get a total of 92 grams per mole. All right, so the molar mass of N2O4 would be 92 grams for every 1 mole. The last molar mass example we're going to do here is going to be calcium nitrate, CaNO3 2. All right, when people see this, they get a little scared because they see the NO3 and they think, oh my goodness, a polyatomic. But if you just follow the steps, you'll see that there's no real tricks here. Molar mass doesn't get any more difficult than what we've already done. So the first thing you do is you look at each of the individual elements. So the first element I see here is Ca. All right, and based on the formula, there's just 1 calcium times 40 for each calcium. So that's going to be 40 here. All right, then I have nitrogen, and there's 2 nitrogen. Be careful. These parentheses and this 2 outside, that's going to multiply through. So there's 2 nitrogen times 14 each. It's going to be 28. All right, and then the last element is oxygen, and again, that 2 multiplies through, so there's 6 oxygen. 2 times 3 is 6, times 16. All right, so when you do that, you get 96, and then when you total these all up, you get 164 grams per mole. Okay, so again, even though there's a polyatomic in there, you just look at each individual element. Ignore the polyatomic itself. We only care about the elements that we can look up directly on the periodic table. The next idea we're going to look at is percent composition. Okay, so percent composition is just trying to figure out how much or what percent of an element there is in a compound by mass. Okay, so it's a pretty easy calculation. You're just taking the mass of the element over the mass of the entire thing. All right, so it's pretty much like how you would figure out your grade on a test. You would take the number you got right over the number you could have gotten right and times 100. So in this case, when you're doing a percent composition, you take the mass of the individual element you're looking at, you put it over the mass of the entire thing, divide it, and then you times by 100. All right. So if you look at this little um, pie chart here for potassium chromate, it's showing you the percent composition of these elements here by mass in the whole thing. So if you look at this, all right, potassium makes up most of the mass of the compound. And people might say, well, how is that possible? There's only 2 potassium in the formula, but there's 4 oxygen. Shouldn't the oxygen make up more of the mass? Well, no, because each oxygen only has a mass of 16, whereas potassium, even though there's only 2 of them, has a mass of about 39. Okay, so you have to take into account the mass of the elements, how many there are, and then the overall mass of the compound. So percent composition is a pretty easy calculation. You just need the mass of the element you're looking at over the mass of the entire thing times 100. I gave you the entire work here for this first example so you can kind of see it before I actually walk you through some of these examples. So this problem wants you to calculate the percent composition of a compound that's made of 29 grams of silver and 4.30 grams of sulfur. Okay, so remember the formula here for percent composition is the mass of each element over the mass of the whole thing times 100. Well, if you notice from the problem, they gave you the mass of each element. Okay, in order to do the percent comp, you need the mass of the entire thing. Well, if you have the mass of each element, you need to just add them up, and that gives you the mass of the entire compound. Notice I wrote the formula of the compound here. That's not even important, okay? All you need to do is take the mass of each of the elements, add them up. Now you have the mass of the entire thing. Now you can use your formula. Mass of the element over mass of the whole thing times 100. So when you do that for silver, take the mass of the silver over the mass of the entire compound times 100, and you can round these. It comes out to be about 87% for the silver. I always say just round them to a nice, pretty whole number, but the key is for these percent composition problems, you're going to have more than one element, so you need to label the percent with the element. All right, it's not a guessing game of which percent goes with which element. So you have to explicitly label that there's 87% of the silver here in that compound. All right, so then you can do it for the other one. I know you could just take 100 minus 87 and get your answer, but sometimes this is helpful to do this to make sure you're correct. All right, you take the mass of the element over mass of the whole thing times 100. So you have the mass of the sulfur from the problem. You have the mass of the whole thing, which you found, times 100. And when you round, it does come out to be about 13% for the sulfur. Again, notice each is labeled with the element, and you can round them to the nearest percent. We're going to try another example here. Again, some people usually pick this up pretty quick. You're more than welcome to try it on your own and then see if you get it, or you can walk through the example with me. So we have a compound that has 9.03 grams of magnesium combining with 3.48 grams of nitrogen, and we want to know the percent composition. All right, we need the mass of the element over the mass of the whole thing times 100. We have the mass of each element from the problem. We just need the mass of the entire thing here. So the first thing we're going to do is 9.03 grams, okay, plus the 3.48 grams for the nitrogen, all right, and that's going to end up being 12.51 grams, okay? So now we have the mass of each individual element and we have the mass of the entire thing, so we can start doing the percent composition. I'm going to start with the magnesium. The mass of the element here, mass of the magnesium is 9.03 grams, and I like to label this so I know which one I'm doing. It's all about keeping this organized here. All right, and then the mass of the whole thing is 12.51 grams. Okay, so mass of the element over mass of the whole thing times 100. All right, and when you do the calculation, it should come out to be about 72% for the magnesium. Okay, so that's going to be an answer here, so I'm going to circle it. And then when we do this for the nitrogen, mass of the element, there's 3.48 grams for the nitrogen over mass of the entire thing, 12.51 grams times 100. All right, and when you do that, it does come out to be about 28% for the nitrogen. Again, both are labeled. You can round both of them to the nearest whole number. Just be careful. You need to make sure you're showing your work for these. All right. This is the minimum amount of work you need to show for this type of problem. You have to go through and show what you're doing and show your setup. For this example, they want you to calculate the percent composition of NaHSO4. All right, so you'll notice immediately that this is different from the previous examples we've done. They didn't give us any numbers, okay? We want to try to find the percent composition without any numbers. This is how you see percent composition a lot of the time, all right? So remember, to do this, you need the mass of each element over the mass of the entire thing, all right? So without any numbers, you can use what we just learned previously in this video, molar mass, to be able to do this, okay? So if they ask you to find the percent composition of a compound, you need to do the molar mass here. So I have 1 sodium times 23. It's going to be 23 just for the sodium. I have 1 hydrogen in the formula times 1. It's going to be 1. All right. I have 1 sulfur times 32. It's going to be 32. And I have 4 oxygen times 16 is going to be 64. All right, so now I have to total this up, and I get 120 grams per mole. Okay, so I just found the molar mass of that compound. But remember, we want to do percent composition here. That's what this asks for. This asks for percent composition. So you just did the molar mass. You're not done. All right, in order to do percent composition, you need the mass of each element over the mass of the entire thing. Well, if you notice, when you just did the molar mass, you just found the mass of each element right here. And you just found, by totaling them up, the mass of the entire thing. Okay, so now you're ready to do your percent composition. So for the sodium, you have 23 over 120, mass of the element, over mass of the whole thing, times 100. Again, you need to show all your work here. It's going to be 1 over 120 times 100 for the hydrogen. It's going to be 32 over 120 times 100 for the sulfur, and 64 over 120 times 100 here, okay, for the oxygen. So mass of the element over mass of the entire thing times 100. So when you do your math here, you should get about 19% when you round for the sodium. It comes out to be about 1% for the hydrogen when you round. You get about 27% for the sulfur. Again, notice I'm labeling all these percents with the element that it corresponds to. And when you do the oxygen, the 64 over 120 times 100 comes out to be about 53% for the oxygen. Okay, so now these percents should add up to 100. Sometimes due to rounding, they might be either like a little above or a little below, and that's okay because we do allow you to round to the nearest whole number. But you do need to show your work and you need to label all your answers with the elements. So that's just kind of a different way to do percent composition here. So we got one more final one here to try. We want to find the percent composition of C2H4. Again, there's no numbers here, so you're going to have to find the molar mass. All right, but we like molar mass. It's pretty easy. So we got 2 carbon times 12 each, all right, is 24. And then we have 4 hydrogen times 1 each. It's going to be 4. So when we total this up, we got 28 grams per mole. All right, in order to do percent composition, you need the mass of the element over mass of the whole thing times 100. Okay, if a problem just asks you to find molar mass, you're done. You found the molar mass, but this asks us to find the percent composition. Okay, so we have 24 is the mass of the element for the carbon over the mass of the entire thing, which is 28, times 100. Okay, when you do that math, it's going to come out to be about 86% for the carbon. Okay, so you know now it should be about 14% for the hydrogen, but you still need to show it. So you have mass of the element, which is 4, over mass of the entire thing, 28, times 100. All right, and it does come out to be about 14% here for the hydrogen. Okay, so again, you can round to the nearest whole number percent, but you need to label the percents with which element it corresponds to.